So it all starts with a to the power m times a to the power n, a to the power m. And okay, let us do one thing. Since we discussed y is equal to log x to the base a, okay, and then we discussed that when we take the anti-log, so anti-log will be a to the power y is equal to x, and then we will take the log of x only, like this is log of x only to the base a. So I'm just trying to keep x and y only in exponents also. So the first law will be x to the power m times x to the power n will be x to the power m plus n. Second one will be x to the power m divided by x to the power n is x to the power m minus n. This is just like a revision. If I have x to the power m times x to the power n, then it will be x. If I have x to the power m times y to the power m, then it will be xy to the whole power m. Like we can take it complete power. And this thing is applicable if it is x to the power m divided by y to the power m, then it will be x by y to the whole power m. It will be applicable there also. If I have x to the power m times n, then it will be x to the power mn. If x to the power 0 is there, it will be 1. If 1 over x to the power m is there, it will be x to the power negative m. If x to the power 1 over m is there, then it will be root of m. It will be same as root of m. And lastly, if I have x to the power m by n, then it will be square root of n or root of n and x to the power n. Okay, be quick, write them. I'm just making the boundaries so that it will be easy for you to understand. These are all different properties. And based on these properties only, we are going to learn all the properties and laws of logarithm.
So these are not according to log. We're just doing them as revision. Then we're doing according to log, right, sir?
Yeah, these will be like this is the base with
Yes, sir.
respect to which you will understand log.
All right, sir.
Okay, so you can take them. These are according to log only.
So yeah, and the question that I asked a doubt for it was, I think the part of like the fourth thing only, the x1 by m is equal to m root
Yeah.
x.
It will be covered. That base change formula is there in log. We will cover that.
Yes, sir. Okay, sir.
So all of you quickly write them because when we'll understand for log, it will be easy for you to recall and use that.
Sir, do you have a link for how to use log on calculator?
Yeah, I'll send it.
Because, okay, yeah.
Nowadays on YouTube also there are shorts videos. So most probably like whatever you search, na, like for such things, always write shorts in front of that. So you will get a video which will be under 1 minute. It will save your time in case if it is correct. In case if you land to some wrong video, then also it will not be that waste. Okay, is it done?
Yeah.
Okay. Now let us have a look at the properties of log. There was one handout. Okay, just give me a minute. I couldn't find. Let us do it directly then. first law. If I have log of x plus log of y, in all of them I'm considering base as same. Okay, that's why it is not required to be written. But in case if anyone just out of curiosity wants to write, you can just write a. A is any general number. Okay, so it will be log of x, y. Now, if you will correlate this with
So is it correct to correlate it, or like mathematically?
it is, they're actually of same family. So it is definitely correct to correlate.
So we can see it, so it's fine.
I realized later that I can also write. It will take less. Okay. What you have to compare? If it is log a, log x plus log y, means if it is m plus n, then it will be log of x into y. Means when this is a product, then it will be added. Similarly, when we look at the second property, if it is log x minus log y to the same base, then it will be log of x by y. This is same as x to the power m divided by x to the power n, which will be equal to m minus n. So now correlation doesn't mean that they will be exactly same. But when you will look at them now, you will understand that when it is division, there will be minus sign. When it is multiplication, there will be plus sign. That is exactly what is happening over there also. Okay. Log is just a manipulated form of exponential function. To be precise, log is inverse of exponential function. So they will have a similar properties every time. Means there will be some of the other correlations which we can make.
So do we not need to know the proofs for these?
No. We have to understand the application of these in the questions. Okay.
Yeah.
So after writing all of them, we will see the questions and we'll understand that how we have to apply them in the questions. Next is log of x to the power y. Okay, in all of them I'm not writing base because right now don't make it complicated, make it as simple as you can. Base you can assume anything by default. I have shown in the first case. So this will be written as y log x. Okay, this y will come in front. There is no similar property which we have over there. So that's why I'm not writing anything as a correlation. Then the next which we have is log of x to the base x. Log of any number to the same base is always equal to 1.
1.
Okay. Then number 5 is log of 1. Log of 1 to the any base. I'm not writing the base because it can be any base. It will be 0 always. Okay. And log of 0 to the any base. It will be not defined. So at last what I have written, these are not properties, but these are other results, which we have to use in the questions as per the requirement. So till here, is there any of the property where you have any question?
So the third one, so
Yeah,
how is possible?
So
okay.
I think if you give an example, it will be more clear because I understood like that only. So log a, if you give an example of this, like in real, it will be easier. So log base 3 and then raised to power x.
Okay.
So if you, yeah, but I understood this though.
Okay, first of all, Rishon, we are not going into the proof of that. Okay. But yeah, the proof can be understood with the help of how we got log. Okay. Like if you want to understand that, we can just go on to the actual definition of log. Log started from here. Y is equal to a to the power x. This is an exponential function. Okay. In the exponential function, if I take log on both the sides, so it will give me log y is equal to log of a to the power x. Okay. Now here it is assumed, like, because I am taking log, so I can decide the base. It is always in our hand, okay, when we are solving it. So I'm taking the base of this log as a, okay, because it is the base of this exponent is a. Okay, so from here I will automatically get log y to the base a is equal to x. This is like one of the verification of that. I cannot say that it will be proof, because we have defined log using this only, that x will come in front, and this is how we get x is equal to log y. So it may not be that convincing if you're taking it as a proof, but let's say if I have one more question, if I have 81, log of 81, and over here base is 3. Okay, so how this property will be actually useful? You just try to see that if 81 can be written as base of 3 to the power of something. Questions will always be framed in such a manner. Okay, so I can also write 81 as 3 to the power 4, because 3 into 3 into 3 into 3 will be 81, and base is 3. So the value for that will be 4. How 4? Because this 4 will come in front, so it will be 4 log 3 to the base 3. Log 3 to the base 3 will be 1, and the answer will be 4. Okay, that was what I explained in the last part of previous lecture, that this is why log is useful. That a user will store something, but means user will enter something, but it will be stored in some other form only. Okay, now from here, if you want to get back to this, so you have to recall the definition of log, power to which base must be raised to get the number. Okay, so number is what? Number is 81. 81 is what? It is 3 raised to the power 4. So this base 3 is raised to the power 4 to get that number. So that is why we call it as logarithm. These, if you will take it as a definition, I can understand it will look a bit complicated. Okay, so my simple advice is that it will be better if we just focus them as properties, that yeah, these are used, and with them we will learn how to solve questions, because in questions ultimately means in exam ultimately the questions will be there which we have to solve. Okay, logically I cannot explain by giving any proof. I can give examples to explain these properties. Okay, so instead of examples, we'll directly take the questions. Those will be like live examples only. We are done with all the properties. Okay, there is one base change formula which we will do after few questions. Okay, so let us see them first.
So how many properties did we do? Did we do 6?
Look, if we count the numbers on this slide, then it will be 6. But these two are not properties. These are just general results which can be understood with the help of graph only. Okay, like in some books you will find them also as properties. Like one of the properties still left, which is known as base change property.
Yes,
Okay,
sir.
so that we will do after 1 or 2 questions. I just want to show
Okay.
you the application of these properties, that what type of questions will be asked and how you have to use the properties. Okay, so just have a look at this question and observe. Just observe. Okay, you'll understand everything. It is given that let log of 16. Okay, observe means you have to observe how I'm speaking, because from there the real learning will be there. Okay, because Many students read log 2 16 is equal to log 2 a to the power b. That is wrong. Okay, log of 16 to the base 2 is equal to log of a to the power b to the base 2. Okay, if you are not speaking the base, it is fine. Okay, so where a and b are integers and a is less than b, so we need to find the values of a and b. It is a very simple question where we have to just compare both of them by using the properties of log. How? So on the left hand side, we have log of 16, which can be written as log of 2 to the power 4 to the base 2. On the other side, I have log of a to the power b to the base 2. After that, if you have a very good observation, you need not solve anything because the answer is a is equal to 2 by observation and 4 is equal to b. So you can directly write after this step only. And why I can do that? Because they are equal. So if they are mathematically equal, means it is only possible when the value of a is 2 and value of b is 4. That's it.
Yes, sir.
Okay, so in this question particularly, we didn't apply the property.
Just common
Apply
sense.
the property. Okay, we have just directly compared and we got it. And the next question, hence or otherwise find the value of log of 16 to the base 2. So
We
it will
got
be,
that as a byproduct.
yes. So we can write it down as 16 as 2 to the power 4. We have to make sure that if possible, this base of logarithm should be same as this base. Okay, if possible. In some questions it may not be, then there will be some other thing. But
Yeah, so
whenever
then
it's
it's just
possible,
easy. Then we just get like 1, right? Because
yeah.
now it's just 4.
So it will be 4 log 2 to the base 2 and then it will be 4. Okay. So this was first type of question where we have just used simple understanding about log, nothing extraordinary. Now the other question on your screen. Okay, everyone is done till here. Is there anyone who is writing anything from the screen?
No, sir.
All are clear in both the parts of this question A?
Yes, sir.
Okay. So next question, let log 25 plus log 4 is equal to log C. Find the value of C. So this is the first question where we have to use the property. Okay, which property? Log m, log x plus log y is equal to log xy. Okay, you can even see that base is not important. On both the sides, base is not mentioned. It means it is same. Okay, same means the default base is considered as e or 10. Unless it is not asked, you should not bother about whether it will be e or 10. Okay, they will give you some hint with which it will be confirmed, and both are
So
different.
natural logarithm is also called e, right? They're the same thing, right?
Yeah. But natural logarithm is also written as log of something to the base e. It is also written as ln x. When we write ln x, then we need not write e because ln stands for natural logarithm. Okay, let us solve the question. So the first part is we have to apply that property. Make a habit of also writing the property which you are using. So we are using this log of x plus log of y is equal to log of xy. So that will be log 25 plus log 4 is equal to log c. It will be log of 100 is equal to log c. Compare and get the answer. The value of c will be 100.
Yes, sir.
Hence or otherwise find the value of log 25 plus log 4. Okay. Now here you have to act smartly.
So if it's just 10, we can get it easily then.
Yeah. No, but I'll tell you how to proceed for this.
Okay, sir.
So since the base is not given and by default base will be e or 10. Okay, by default, it will be either of them. Now it all depends on the question. Like in this question, when we do log of 25 plus log of 4, that will be log 100. Log 100 can also be written as log of 10 squared. Now the base of this is 10. So we can take this base also as 10 and the answer will be 2. This is the step where you have to decide the base on your own. Okay. So any doubt in any of this step?
So for the base, we can choose whether it's E or whether it's 10 based on what we get.
Yeah, based on the question. Like it happens in very less questions where there will not be any hint given. Okay. Usually they give the base or they give some hint. But when nothing is given, then what we should do? So we should go with this only, that it is coming out as 10 to the power 2. Now just imagine if it would have been log of 25, then it will be log of 5 to the power 2. Then also I would have taken base as 5. Okay. This was like an exceptional thing. Usually you can assume that base will be given in the question because then it will be all controversial.
Yeah.
People will have different perception and all will be correct in that case.
So you can just take the base based on what you get, like based on what number you get.
Yes, yes. This is just one of the perception. Generally, when base is not given, as I told, it will be either E or 10.
Okay.
Okay. So like in that question also, we were getting 10 only, na? 10 to the power something. So it was very easy for me to think of that base can be 10.
Yeah.
Okay.
Yes, sir. Got it.
Let's see this question. Okay, everyone is done with this? Anyone writing anything from the screen? All are done. Rajveer, Raghav, Madison, Rishon.
Yes, sir.
Yes, sir.
Rishon, till here, do you have any doubt?
No, sir.
There is one more difference. Okay, since in CBSE, there were many things for which derivations were there. Okay, international curriculums are just opposite to that. Okay, in most of the things that look, derivations have very less probability to be asked in exam. That is for sure. You can just say negligible probability in IB and even UK curriculum also. But sometimes in some topics, if it is needed, I will definitely show you the derivation, but that will be out of the scope of exam. You have to just learn how to apply the concepts in the question. That will be more than enough. Okay, that is a big difference between Indian curriculum and international curriculums. Okay, everyone try this question. And that is equal to log of d to the base 5. 500 by 4 will be 125. So from here, by comparing, I can get the value of d as 125. Okay. Now, in the next part, they are asking hence or otherwise find the value of log of 500 minus log 4. Okay. Log of 500 minus log 4 is log d. So I can directly work on log of 125, that is log d to the base 5. 125 is 5 cubed. So this will be written as 3 log 5 to the base 5 and the answer will be 3. So that is the answer for second part. This was for first part. Doesn't matter. It's like a facility with which you will be able to solve question properly. Okay. And why we need to change the base? So as per the question, if it is ever required to change the base to something with which you can get the answer, you will apply this method. Okay. Now what is that? Let us see. If I have log of x to the base y, okay, and I need that my log should be at the base 10 or at the base 5 or any random base, let's say a. So I can write it like this: log of x to the base a over log of y to the base a. This is called as base change formula. For this also, instead of going into the proof, we will solve one example, and then you can check both LHS, RHS. If you want, you can check it in the calculator also. But yeah, it will be same only.
So just from what I understand, so it's like, so log ax, whatever it is on x, it below also will be that only log a. So if it's log base 3, it will be log base 3 again, and then whatever was the base on the first one on top, that will be the thing over there. Is that correct?
Yeah. Well, let me complete. Yeah, I'm
Oh
not
yeah,
done
sorry.
yet. Okay. There are a few more things which I want to speak. Then you can. I will give you time. Okay. So let's say if I have log of 125 to the base 25. Okay. And I want to solve this. Now, how it can be solved? So for that, you can firstly write like this: log of 125 upon log of 25. You can see that I'm not writing the base, because at times, what is the base, it really doesn't matter. It should be same. We have to just make sure. Okay. Like I have applied base change formula means both the bases will be same, whatever it is. So you need not write. Okay. And if anyone wants, then yeah, you can definitely write it down as anything, whatever you want. Okay. I'm just writing A. Next step, log of 125 can be written as log of 5 cube upon log of 25 can be written as log of 5 square. Okay. Let me take it. Then after that, the numerator can be written as 3 log 5 to the base A. Denominator will be 2 log 5 to the base A. You can see that whatever was the base, it was really not important. The important thing was that after applying base change formula, I have reached to such a step where they will be eliminated and I will get the answer without even using calculator. Okay, you can get the answer directly by putting this thing in the calculator. Okay, but if a question comes and you have to show the steps, then these will be the steps which you have to show. So you can see that base change formula is just acting like a facility with which I got the answer very easily. Okay, so it is not more than that. You call it as property identity, that is not important. Okay, so this application should be clear to everyone. And now questions are open if there is anything motive. So what I'll do, irrespective of what base I'm taking, I'll just apply base change formula on both the sides. So it will be log of x over log of 3 is equal to log of 81 over log of x. Okay, and then it is simple mathematical multiplications. Okay, so on the left hand side, it will be log of x whole square. And on the right hand side, it will be log of 81 times log of 3. Okay, log of 81 times log of 3. Okay, now this log of 81 can also be written as 3 to the power 4. Okay, 3 to the power 4. And now I will use my power. What is my power? That I can take any base of my choice. Okay, so which base I am taking? I'm taking 3 as the base of the log. Okay, so if I take that, you just look at the RHS. This 81 is 3 to the power 4. 3 to the power 4 will be 4 log 3 to the base 3. So eventually it will be 4 only. I'm just writing down the steps so that everyone can understand. This is log 3 to the base 3. Okay, and I can just rewrite the base at every step. It is better
Well, we
to
can take any base we want. Oh yeah, the base is the same on the left, so we have to take that only, right?
yeah. Okay, so now I'm having only 4 over here, and I have log of x to the base 3 whole square is equal to 4. When I'll take the square root of it, log of x to the base 3 is equal to plus minus 2. Very important. This step, I can guarantee that out of 10, more than 6 or 7 students will do it wrong. They will not write -2. Okay. Now, there is often a small misunderstanding which develops over time when we study log. Before continuing this question, I'll tell you that.
So can you go back to the previous question? Yeah.
No need to write, no need to write. I'll get back
No,
to
so I
that.
am confused a bit in that question. Yeah.
You were doing it, na? It's okay. We will go back
No,
to
so I'm
that.
confused in that question. Okay, never mind. Yeah.
I'll get back to that. Okay, no worries.
Okay. Yeah.
This is the graph of log. Okay, there are few observations which we have to make from the graph of log. That, let's say this is y is equal to log x. Okay, first observation is that log x is not defined for negative values of x. Okay, all of you can see from the graph, not defined for negative value of x means there is nothing in the negative part of the x-axis. There are no inputs which you can put negative. In simple words, this x value cannot be negative. What you put inside the log can't be negative. You can try it out in the calculator. It will give you math error because log is not defined for negative value of x. So this thing is misunderstood as that log can't have negative value. I repeat again, log cannot take negative value versus log can't have negative value. What is the difference between both of them?
You're basically saying that y can't have a negative value, whereas it's x that can't have negative value, right?
Okay, I'm basically saying that x can't have negative values, but y can have negative values.
Yeah.
Okay, I repeat again what I said. For log x, negative value of x is not possible. Log x is not defined for negative values of x, but log x can have negative values. Okay, it can have negative values. It is evident from the graph. You can see this portion of the graph, it is all negative y values. Okay, and then if you remember, I told you that log of 1 is always 0 irrespective of the base. So this is that point 1 comma 0. It will be there in all types of log functions. Okay, so coming back to the previous, if you want, you can just leave it for now. Okay, you can write it later. Coming back to this question, and before moving ahead on the question, Raghav, you are having some doubt. Go
Yes,
on.
sir. The main doubt I had is okay. So in the left part, log 3 by x, we take the 3 as the base, right? So that's why the on top is also log 3 by x and below it's log 3 by 3. That's what we do there, right?
Yeah.
But in the second part, log 81 base x, we take the base as 3. So do we do that because it's there on the left, or do we do that because we have the choice to put whatever that we want?
We have to do the same for both the sides.
Okay, so if it's log base 3 by x on the left, then on the right also it has to be the same.
Yeah, look, there is no connection with this 3 and why I have taken 3 over here. First of all, be clear with that.
Yes, sir, that's why I'm
Any
confusing.
other number also, but why I have taken 3? Did you remember when I chose to take base as 3? I told that over here now I will use my power, and what is my power? That I can choose any base of my choice. So why
Yeah.
I chose 3? Because both 81 and 3 were powers of 3. So I know the property of log that when I will raise it to some powers of 3, that will come in front and the log part will be gone.
Okay, yes, sir.
Okay, that was the reason I chose 3.
Yes, sir.
Okay, now let us continue from here. After this, I have to use like anti-log thing. Okay, so what do we do in anti-log? We raise this base of log to the power of this number. I repeat, we raise the base of log to the power of this number to get the value of x. We were finding log of x. So I can get the value of x by doing this 3 to the power plus minus 2. I'll be getting two values of x, 3 to the power 2 and 3 to the power minus 2. So x is equal to 3 square and x is equal to 3 to the power minus 2. Both of them will give me the same answer. This question was to get the x value. So there will be 9 and 1 by 9 final answers.
Okay, sir.
Sir, how will the graph look?
We are going back to the graph again. Before that, are you clear with this?
So
I
can you
just
explain why you took base 3 again? And in general, can we just take any base if it's suitable?
look, in general, we can take any base, okay? But questions are actually framed in such a way that you will not be having all the choices. You have to understand that as per the question, what is the suitable, most suitable choice? Okay? So understand this thing that I could have taken base 5 at both the sides. There was no obligation. If I will take base 5 also no, on both the sides, no problem. But then base 5 will not give me my answer. I want to get rid of log. Okay. I have to think of base in such a way that I get rid of log. I don't want log terms. So at least from the right hand side, I just removed all the log terms. I got only 4. So that was the mindset behind taking 3. It will develop with practice. Okay, like it is not something like which you will get in a click. Right now I'm telling you, when you will practice more questions, it will develop. Okay, is that thing clear to everyone?
Yes, sir.
Okay, let us go back to the graph of log. Okay, in the graph of log, once again I'll tell you that there will not be anything in the negative part of x-axis because log is not defined for negative x. Means if you want to find log of -2, it's not possible. But on the flip side, people understand that if log of -2 is not possible, then log of something to be negative value is also not possible. But that is wrong. Okay, the reason is you can see the graph. So in the graph, these are all negative values of log, and those are particularly obtained when the base of log, not base, when the value of log is between 0 to 1. Let's say if you're trying to find log of 0.5 to any base, whatever is the base. Let's say I am trying to find at 5 only. Okay, I can take any base. So I will get negative answer from here. Okay, is that clear to everyone? I'm not solving it. It's okay, we need not solve it, but I will get negative answer. You should be clear with that. Okay, so in the graph, is there anyone having any doubt? I will attach few questions of log in these notes only.